In this video, we're going to look at the maybe monad. And again, if you're interested in knowing what exactly a monad is and understanding some of the properties behind the monad entity, I highly recommend watching some of the earlier videos that I've created inside the monad playlist. Here, I'm going to get straight away into defining what a maybe monad is. So let's do first thing. Let's say I have a function f here. I've got some kind of a function f, and this function f over here goes from some integer as an input and gives you back some other integer as an output. And let's say I've got another function g. G is a function that has the same type signature. It takes in some integer as an input and gives you back some other integer as an output. Okay, and if I were to define function composition between f and g, function composition, looking at that circle there as a function composition operator, is defined from a type signature point of view that it takes in one function that goes from, let's say, from a to b. It then takes in a function that goes from b to c, and it gives you back as an output. It gives back as output some function that goes from a to c. So let's just put a parenthesis here. So that's my function. This is my function, some function 1. And I've got another function 2 here. And the function composition between 1 and 2 in this case gives you back a function that goes from a to c. Okay, so what would that imply for function composition of f, function composition with g? What's the type signature of f or g there? F or g is going to be a function goes from a to c. Okay, and again, just to be clear, let's just do some kind of coloring here. This function f over here, this function f over here has a type signature that goes from B to C, and I've got the function G here that goes from A to B. Okay, and f or g is going to give you back a function goes from a to c, and in this case, because this is really straightforward, everything goes from integer to integer, integer to integer, you're going to get back, in this case, a is happening as an integer and c over here acts as an integer. So what you get back is basically a type signature of a function that goes from int to an int there. Okay, and again, if you want to look at the implementation of this thing, it's nothing but it's going to give you a function, right? F or g basically your function goes from int to an integer, and this is going to be nothing but g of x. You first apply g on whatever this x is, and after that you're going to apply f on the entire piece of the output of g of x. Okay, so this works, everything works nice here, everything is great there, and what I'm going to do now is I'm going to define a different function f prime and a g prime, such that f prime is more or less very similar to a function that goes from int to an integer, but it basically is now a function that goes from an int to a maybe integer, and g prime is a function that goes from an integer to a maybe an integer. Okay, now what would be the function composition of f prime with g prime? Well, f prime g prime, I know that function composition of f prime g prime is going to give back a function goes from a to c here, and in this case a over here happens to be an integer. So let's just make this a little bit more clear. So this is going to be some kind of function that goes from basically from a to a c. Okay, and again, this a and c is, again, to be clear here, g prime is basically a function that goes from an integer to a maybe integer. So this is acting as my a here. Okay, and this b over here is going to be this piece. That's my b there. Okay, and then finally I've got a function f prime, the outer function, which is this is acting as my b there, and this piece over here is acting as my c. So in theory, if this were to succeed, f prime, function composition with g prime, it should have a type signature that goes from a to c here. But one of the implicit constraints here is that the type of b here, which is the output of g prime and the input of f prime, must exactly match. And what I have here is basically a mismatch. I have a mismatch here. So if I look at this b over here, if I look at this b over here in red there, and if I look at this b over here, I can see that I have a type mismatch. Maybe int is not equal to the type int. They're completely two different types there. So this is definitely going to fail. This f prime function complex g prime is definitely going to fail here. So what I really need here is some kind of a helper method. Think of some kind of a helper method such that if I can somehow upgrade the type of f prime. Let me explain that. So what I'm going to do is whatever this f prime here is, okay, so if I take the assistance of I'm just going to rewrite this function here, okay, so I have my function composition operator there, I have my g prime there, okay, g prime takes in as an input, it takes in as an input some integer and gives you back as an output something that is a maybe an integer. What I really want here is that the output of this g prime, the output of this g prime, which is basically maybe integer, the output of g prime is going to become the input of this piece in orange there. Okay, whatever I'm going to put in that orange there is going to consume as an input the output of g prime. That's simply the definition of function composition, right? I'm just applying the definition there. But over here, the output of g prime, which is still in this case a maybe integer, cannot be fed into f prime because f prime expects an integer. It expects an integer, and there's a mismatch in my types there, and that's why this is a failure there. So somehow, if I can get this orange box, if this orange box to take in as an input a maybe an integer, then I have a type match where this function composition is actually going to succeed there. So what should I do in this orange box there? So what I'm going to do in this orange box is I'm just going to rewrite this orange box a little bit bigger here. So I'm just going to rewrite this a little bit bigger. Okay, whatever that orange box is going to be, and let's just put a function composition again there, and let's put a g prime. Okay, so this piece in orange, which is going to take in as an input, whatever this piece is in orange is going to take in as an input, let me be consistent with my colors too. So it takes in as an input maybe integer. I mean, that's the only constraint. It could give back as an output anything else that doesn't matter, but at least as from an input perspective, its type must be consistent and in sync with the output of g prime. Okay, so we are going to do something slightly different here. Inside this orange box, I'm going to have a function called bind of f prime. Okay, bind of f prime. This piece, entire piece in orange there, bind of f prime, is going to take in as an input something that happens to be of type maybe integer. Okay, again, let's think a little bit more carefully here. So bind is acting as some kind of a helper method. Bind is acting as some kind of helper method which takes in as an input f prime. Okay, so bind takes in as an input something that happens to be f prime, and f prime's type signature is int to maybe int. It takes in int to maybe int. Okay, great. And what does it give you back as an output? Well, bind f prime is basically this entire piece in orange, which takes in as an input maybe an integer. Right there, I'm saying that's exactly the same thing, that it takes in as an input a maybe an integer. So this is going to be maybe an integer, and what it gives it back as an output is basically the output of your original f prime, which was in this case maybe integer. So in this case going to be again maybe some integer. Okay, now again let's just think carefully what has happened here so far. So I have bind takes in a function, it takes in some kind of a function f prime there. Okay, let's call it some function f prime there, and what it's simply done to f prime is completely upgraded it. It's upgraded the input type. It's upgraded the input type such that the input type over here now is upgraded from an int to maybe an integer. Okay, and the output over here is basically the type signature of the output is basically unchanged. Earlier f prime was giving back maybe integer, is still going to be maybe an integer. So now, what is the function composition of bind f prime function composition with g prime there? Okay, so let's see if our types match up now. G prime is a function that takes in as an input some integer, right? G prime takes in some integer and gives you back maybe an integer. And what is bind f prime? Well, bind f prime is maybe integer to maybe integer. So this piece in orange, this entire piece in orange, if I write the type signature of this entire piece in orange here, okay, and I'm just going to be, again, I'm using a slight shade of pink there. So this piece over here is from maybe an integer to maybe an integer. Remember, this type signature is the entire piece of this box in orange. The out, the output over here matches the input of that orange box. Okay, these things match here, and because these things match there, the function composition of bind f prime, function composition of g against with g prime there is going to give you back, some kind of a function, right? It's going to give you back some kind of a function. The entire type signature of this entire piece there is going to be some kind of function that goes now from an integer to maybe an integer. Okay, so this is what bind is doing here. It's simply helping me, is simply allowing me to somehow upgrade that f prime such that the function composition actually succeeds there. Okay, so what we've done here so far is we have defined at least a type signature. I still don't know what the implementation is going to look like, but at least I know what the type signature is for this bind method. Now, what we're going to do in the next video is we're going to basically look at this type signature of the bind method and try to provide an implementation to that bind method. And we're going to look at the return method, and we're going to look at a couple of monad laws that basically gives a final conclusion, a final closure to this entire maybe monad.